Hi everyone. Today I am meeting with Simon Hall, who is from the Mechanical Engineering Group. Hi Simon, welcome. Can you start by just introducing yourself and explaining a little bit about your background?
Sure, Claire. Yep. So, as you said, my name's Simon Hall. I've been a mechanical engineer for about 25 years. So the way I got into this is it's probably the way a lot of people got into it, just basically tinkering at home as a kid, pulling things apart, trying to figure out how they work, sometimes managing to put them back together. Um, and I guess engineering education just sort of formalized that. Like I started learning about, oh, that's why that did or didn't work when I tried it. But generally, yeah, just a sort of a upbringing of tinkering and just being interested in how things work.
Yeah.
It's really what fueled that. And then also going to things like career fairs and just sort of being involved with Engineering New Zealand, who ran various schemes like site visits
Mm.
for students, just to sort of see what engineers do. So I got tours of things like power stations, um, and just sort of cemented to me, yep, this is what I want to do. This is really interesting.
Yeah, that's great that you had those opportunities to go off site and meet real people and real jobs and see how they're actually applying it in the real world. I think that's super key because, teachers obviously can't have all that information to hand. So that's great you had a teacher that did that. So what does mechanical engineering cover?
It's quite broad. So covers things like product design. We're surrounded by products, and most of the physical part of that was designed by mechanical engineers. It also covers the processing, the manufacturing processes, as well as the design. Um, yeah, it covers machinery, industrial machinery, production machinery. So again, designing that machinery, um, and then operating it. So there's a lot of mechanical engineers involved in operations as well, basically making factories run.
Yeah,
So a lot of that is things like automation design as well, sort of ties into mechatronics there.
yeah,
Um, and we also get into a bit of structural design as well. So like some of the machinery we design can be really big, so you need to design a structure to hold her up. So there's a little bit of overlap with civil engineering in some ways. There's also thermodynamics, so sort of ties into process engineering. So if you're designing sort of the thermodynamic side of something like a power station, or the boiler system for some sort of plant that uses heat and steam and things like that to do its process.
hmm. Oh, cool. Okay, so
Yeah.
in a real basic level for kids at school, it would be your potential digital technologies, DVC, hard materials, like getting in the
Hmm.
workshop. I think you said it
Yep.
perfectly.
Yep.
Tinkering is perfect,
Hmm.
which is exactly what those ones are. And how does MEG Mechanical Engineering Group support engineers?
So we try to support engineers at all levels, and we put it out there that we're basically our group is for anyone with an interest in mechanical engineering. So it doesn't have to be professional engineers. It can be tradespeople, technicians, as well as professional engineers, students. Um, so essentially, I guess we sort of start at tertiary level, where we help out with things like speed interviewing,
Mhm.
so that the mechanical engineering students can be interviewed by mechanical engineers, and they're talking about common things. Um, we sponsor some of the peripheral activities the universities do, like Formula SAE.
Mhm.
And then for graduates, we're a great source of CPD, continuing professional development. They've just finished university, but throughout your entire engineering career, you're always learning. There's always new things coming up that you need to know about. So there's a constant need for CPD. So we're basically their source for CPD. We run um, technical presentations. So you turn up to an event and you meet a whole bunch of your mechanical engineering peers, and then you watch a presentation about some interesting new thing that's happening. And we do site visits. So if there's some project with a mechanical component going on, things like the central interceptor in in Auckland,
Mhm.
um, various things that Ports of Auckland are doing, um, those sort of things, or various factories, places like Buckley Systems. We'll do site visits there. And then every second year we run a conference with the electrical engineering group. So again, that sort of overlap with mechatronics, mechanical automation, all those sort of topics.
Hmm.
So we run a one-day conference where people can basically just get all that with the gain turned up, right? Lots and lots of events in one day, hear lots and lots of speakers on all different sort of topics, meet lots
Yeah.
of people.
And do you support, I mean, obviously you support anyone who's doing mechanical engineering, but I know like a lot of the rural schools, people who aren't in the big cities, they can still get support from you guys?
Yeah, that's a good question. Because we don't do a lot of on the ground work with sort of the
Mm.
regions, as it were.
Yeah,
Although all our presentations are hosted online, so people can join them online and ask questions. They
yeah,
can watch the recordings later on. Something that sort of came out of COVID, that everyone sort of had to jump online. So suddenly we were able to support our regional members a lot better.
yeah, yeah. And what sort of things do you think people are looking for in engineering graduates? What sort of skills?
Um, I guess an interest in how things work, an interest in exploring new ways of doing things. I mean that's a big reason why a lot of people like to take on graduates. The old people like me sort of get set in their ways, and oh no, that won't work. So it's good to have some new people come along, and maybe they just don't know it doesn't work, but they've got a new way of doing something that might work really well.
Mm.
Um,
Do you see like a lot of changes over time and what sort of knowledge engineers or engineering graduates are coming out with? Does it change a lot or is it pretty much it's always the same sort of thing?
um, I think it does. I think it's got more analytical. So when I started, we weren't sort of doing so much work on computers. There was a lot of physical prototyping and testing.
Mm.
Um, Turns out you don't always need your eyebrows. They grow back.
Overrated.
Um, yeah. So I think there's a lot more computer simulation and
Mm.
analysis now.
Yeah,
Lot more use of those tools. 3D printing, you can do a lot of that prototyping in the office now,
yeah.
without necessarily getting your hands dirty. Plus it's quicker, cheaper,
Mm.
easier in a lot of respects. I think that's changed. There's ways the industry have changed as well. I think there's fewer big manufacturings, the likes of your Fisher and Paykel appliances. They don't manufacture in New Zealand anymore. They still design here. But there's lots of little tech companies,
Mm.
companies that are maybe 30 people and they make some really neat, innovative technical thing, custom designed for clients all around the world. They export a lot of that. There's a lot of startups now. That's kind of a new thing.
Mm.
Lots of startups again with really interesting, innovative ideas.
Yeah. And do you find, I hate to even ask the question, but it's the hot question for everybody at the moment, is how is AI affecting mechanical engineering?
Yeah, so that's a really interesting one. So in my role at the moment, I'm doing a lot of coding. So it's really helping me where just to get the sort of the weird syntax and at least just sort of get their starting point of, oh, that's kind of what I was looking for, where you can
Mm.
just sort of, enter what you're doing and what outcome you want, and it'll sort of help fill in the gaps. I think for engineering design, it can be a little bit useful for generating ideas, maybe just getting the thought process going. I mean, a lot of what we do is it's sort of hidden away because it's all sensitive IP, so it's not really in the
Mm.
in the part of the internet that AI can necessarily access.
Yeah.
Um, yeah, I think those are the main ways. I mean, we're not necessarily doing a lot of report writing and marketing and whatnot.
Mm.
Um, but certainly with I think just sort of generating, the starting point of ideas, um, and just sort of maybe helping just as a problem solving aid rather than
Yeah.
coming up with actual solutions. I think it's
Do you think it has
quite interesting.
potential to move in and take more jobs in engineering?
Um, I think the scary thing is that it's probably going to be really tough for graduates because they get, I'll be honest, they get a lot of the sort of the grunt work when
Mm.
they start as a sort of a way to get up to speed. And I think AI could maybe in time replace some of that.
Mm.
where you can issue a generative prompt and just get it to sort of churn through the that part of things. I think it's not really going to take over what we do because I think there's still going to be a human need to pick over what an AI comes up with. Spot the
Yeah.
the engineering equivalent of the hand with six fingers and say, oh no, that doesn't work. All those sort of things. So I think there's the the landscape's obviously changing, but I think there's still definitely a role for us alongside
Mm. I mean,
AI. I
it's
think it's going to be a tool in the toolbox. It's not going to. I don't
yeah.
think it's going to replace us.
Yeah, and I think there's a lot of, well, I know there's a lot of talk around it, especially in sort of education world, but just creative industries as well. It's definitely an amazing tool that can help. But yeah, the same thing I'm hearing is that it's a tool. It's not going to replace a specific person. It might replace some
Mm,
jobs and make things more time effective and cost effective, which is good. But hopefully not replacing people so much.
mm.
So what types of jobs could you be or could you do if you are a mechanical engineer?
So the one that really interested me from sort of day one was product design.
Hmm.
And so as I said, there's still, there's a lot of startups and these little tech companies still doing, basically, they're still doing product design or machine design. Um, it's another similar one where, you're designing one-off custom machinery. So those are a couple of really good ones for mechanical engineers. There's also these sort of multidisciplinary capital projects. So places like the food and beverage industry, where they've got a lot of really complicated packaging lines, for example, or processing. There's a lot of roles for mechanical engineers there,
Mm,
um, especially around making it safe for people to work around the machinery, as well as just making the machinery work. Because some of those can be really neat things just to watch the way the package product's just flying through something
mm,
really quickly, and it's boxing it or bagging it or whatever.
yeah,
Um, so those are some really good ones. So something we haven't really got into, and it's because the mechanical engineering group doesn't, is building services. That's sort of like, it's kind of mechanical, but it's kind of adjacent. It's sort of treated as its own discipline
yeah,
in at professional level. But that's all sort of your climate control and buildings, that sort of thing.
yeah,
That's another potential if people are really interested in their thermodynamics. That might be something they want to get into.
yeah. And do you find like in the real world when you're outside of school, like when I'm teaching technology in a school, I like to get the kids to work in groups quite often and not as a solo person. Do you think that's definitely a skill that these kids need to have when they're coming out into the workforce?
Yeah, yeah, definitely. So, for example, in product design, you're often working in a multidisciplinary team. So you might be working with electronics engineers, software engineers. Um, you're working with a product manager who might have sort of be a mechanical engineer themselves, and they might just sort of taken a step back. So they're a little bit tech savvy, but maybe not quite.
Hmm.
So you can talk some of the same language, but then sometimes you have to break things down to them.
Yeah.
Um, in say if you're doing machine design on a big complex machine, that might be broken up into sections. So you might be in a team and you're all doing different sections of it, but you have to work together because there's lots of interfaces.
Mm,
You're probably working with automation engineers to make it all work. And on all these capital projects, yeah, you're working with production line operators, um, various other operational people in the place. And if it's a big project, yeah, there might be a few of you working on it as
mm.
well. So yeah, definitely teamwork is very important.
Yeah, that collaboration and being able to communicate and listen. Because
Hmm.
this is,
Yep.
communication is not just about giving your verbal instructions, right? It's actually listening to people and taking all those different things and putting it into play.
Yep.
Cool. Okay. Oh, thanks for your time, Simon. That's actually really interesting. You've covered a lot in that. And I'm pretty sure that would be really helpful to a lot of students out there in the technology field. Thanks for your
That's
time.
great. Okay. Thanks, Claire.